Welcome to Class 9. This is Rendering 3. So part 1 of Rendering 3 will be all about texture mapping. Texture mapping. We have talked about how to draw a triangle now and how we can make a mesh out of many triangles. But that's not good enough. We want to put some color on those triangles. We put like rainbows on our triangles, but we want to actually put a texture map, a full image onto our meshes. And this is how we do that. This is showing the texture map. This is the picture that the artist wants to put on this triangle. And here's a mesh geometry with one particular triangle we'll be focusing on, this gray triangle. The artist wants to put the gray triangle, or wants to put this part of that texture onto that triangle. And the way we do that is what we'll call UV unwrapping. We will use UV coordinates to describe our texture coordinates. We already used X, Y, Z. We even used W. So next up, I guess, U and V, right? So along the X-axis of the texture, we'll put the U-axis, and along the Y-axis of the texture, we'll call that the V-axis. Sometimes you'll see the V going up, and sometimes you'll see the V going down. Just like we did in 380, it's pretty arbitrary. Different APIs are going to do it differently. So what do we do? What we need to do is say somewhere on this texture map is an individual pixel. Like I'm looking at this pixel right here, which is apparently 0.4, 0. So that means 0.4 along this direction and 0 in that direction. So that's right there in this white zone. And for this vertex of the mesh, that's the texture coordinate we will assign. And then we'll go over here to this other corner and we'll put 1, 0. That's an easy spot. That's this corner of the texture map right here. And then finally, for the top of the pyramid, we're putting 0.75, 0.55. Now if we look over on our UV map, that lands right here. So that means this triangle uses this part of the texture map. And as we draw that as a three-dimensional triangle using that texture map, that is what we get. Pixels in a texture, sometimes called texels. So if someone says, that's not a pixel, that's a texel, that's what they're talking about. It's the same thing. We have here a texture map, and that is made up of individual pixels. And since we're using it as a texture source, we'll call those pixels texels. It's just a vocab word. So what we're doing here is we took a three-dimensional geometry and we transformed those three-dimensional vertices into screen space, into device space, and then we're going to render a triangle. We're going to rasterize a triangle in device space. Now, as it's rasterizing, we're going to generate individual pixels within that triangle. Now, after all these transforms have taken place, with the object being rotated and scaled and the camera being moved all around and maybe it's in perspective, those rasterized pixels aren't going to look anything like the original pixels that the artist created in the texture. We are going to interpolate the UV coordinates using, the GPU is going to do this for us, and it's going to just calculate some weird floating point number and then look it up in this map. Here I have an example of a very low resolution image to accentuate this situation. We have a 4x4 pixel grid and is just 16 colors in this texture map. That's 4x4. So as the GPU is rasterizing some triangle that's mapped in here, it's going to sample a pixel here and sample a pixel here and sample a pixel here and sample a pixel here. And you'll notice that I'm sampling more pixels than I have texels. So what should the GPU do here? We have basically two options. We can either say, I want the GPU to take whatever texel it lands in. So for example, if I sample right here, well, that's inside the black pixel, so I'm going to get black. If I use that, we call that point filtering or nearest neighbor filtering. If I use that mode, then I will reproduce this checkerboard shape. Each texel is going to be a square shape as I blow it up. Now, the other option, though, is maybe I didn't mean for this to look like a checkerboard shape. Maybe I meant it to be sort of a gray field, in which case, as I go across here, I want to smoothly blend from black here to white here. So if I sample right there, I should get sort of a dark gray color. And that would be called bilinear filtering. And what that means is the GPU, every time you say, hey, get me the color of this texel right here, it says, well, the 4 nearest neighbors are this one, this one, this one, and this one. It takes those 4 neighboring texels and blends between them depending on how close it is to each one. So if you nail right in the middle of, right here, say right there, right in the middle of one, then you'll get white. But as you creep closer and closer to the boundary next to it, it becomes more and more gray, and in just using a linear blend. So you get a very smooth but blurry image with that. Let's look at an example on a mesh now. So as an example of texturing, let's take a look at this skeleton warrior here. He's going to need some texture. Now the artist has created the texture. Obviously this flat texture has to go onto the 3-dimensional object. So we can see that what they've done is what we call UV unwrapped. So notice how the skull here, the face is reasonably understandable, the face, the front of it. But then they've split the skull right down the middle and unrolled the halves of his skull on the left and the right. And the same thing with the ribcage. Here's the front, the middle, that's how you normally visualize it. But then this is the sides. And then they place the back part over here, and there's some hand and feet bones around here. Here's a jawbone. Let's look back at the model again. These parts then need to be applied to this 3-dimensional shape. So what we'll do is at each of these vertices, this is a vertex right here, and showing the vertices, here's vertex, 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 vertex. Let's look at this one, for example, the center of the eye. We need to map the center of the eye right here to this center. We need to map the ridge of the nose to this location on the texture. So what we'll do is each vertex, and let's look at a vertex again, say the peak of the nose bone. That vertex will record the coordinates on the texture where its part of the texture is stored. So it'll go in here and say these coordinates, this UV coordinate right here, what does that look like? It looks like maybe, say, a third or a quarter of the way to the right, and I'm going to say a fifth of the way down from the top. And so that's right there. That's what the UV will say, is to use that coordinate for that vertex. And that's how we'll apply that. And this is what it looks like when we apply that texture. Let me put his helmet on too. Helmet's a separate texture. So that's what he looks like once he's been textured. Now, you can see how pixely the image is here because this texture is set up to be very low res. It's set up to be only a 256 by 256. So when we zoom in close like this, we get these big fat pixels. Let's instead show what bilinear filtering will do with that. So now it's nice and soft and smooth. This shows the effect of using those interpolated pixels instead. We'll, instead of just showing whichever pixel is closest, we'll take the neighboring pixels and blend them smoothly so that most of the jaggedness has been removed.